I'd like to talk to you about how radical change is coming to data science jobs. A little bit about me. I graduated in 2009 with an MSI in Information Economics. 2 years later, co-founded the company that I'm CTO and co-founder of today. I hire a lot of data scientists, and I work with a lot of data scientists in large organizations. I joined the UMSI advisory board about 10 years ago now, and 3 years ago started as a lecturer. I teach a section of 699 Big Data Analytics, so if you like this talk and my rapid cadence of talking, you can take that class next semester. This is based off a Forbes article that I wrote in 2019. If you want a little bit longer version, go look it up. This is going to be a little bit updated and a lot shorter. I want to talk about the landscape of data science jobs because this is really a new field. It experienced a big gold rush in the end of the last decade. So you had these massive investments in tech platforms, in hiring talent, in building capabilities for enterprises. Literally every Fortune 500, 1,000, 2,000 enterprise had to have some sort of data science capability. The educational institutions like UMSI built infrastructure for training data scientists. This includes programs like MADS and our big data specialization at SI that I'm involved in. But the AI-powered tools and the automation around data science is rapidly evolving. So the question is, what does a data science job look like 5 years, 10 years from now? What I want to talk a little bit about is based on what I've seen in software development. Because when I started my career as a software developer in the 90s, what a developer did was much different from what a software developer does today. And a lot of that is because the tool chains and the products that you use have rapidly evolved to let individual developers become massively more productive. So let's look at what the new tools are that data scientists are using and how that impacts the new roles. So I want to stress that data programming ecosystems, things like Databricks, things like Snowflake, things like Azure Fabric, are these key fundamental big Lego bricks that now take a lot of the crunching that you would do with the data and abstract it into larger functions. So a lot of times you don't even have to think about how to parallelize things or how to scale things. You have more compute on tap with cloud computing than we did a decade ago, largely. A lot of people were on the cloud then, but now almost everyone who I work with is working in a cloud-based computing environment and has a lot of compute available on tap. You have what we call domain-specific schemas. So these are ways of data warehousing data specific to an industry or specific to a type of function that's been standardized over time. So you're doing a lot less data munging. You're doing a lot less effort in terms of collection and filtering because that data has been structured for you by building blocks under it. And then there's business platforms that have been integrated into these. So you may be working in a platform where you already have data stores, you already have a lot of what you need to develop, where previously you were going to the source of a siloed application, or you were working off of maybe a more unstructured data source like CSVs in a data lake. There are also better tools for data quality and data cleaning. You can do that a lot faster now. You can discover anomalies. You can visualize data a lot easier than you could 10 years ago. And the generative AI programming tools, this is something that I didn't see in 2019 that has really made a big difference. I personally can't program Python pandas anymore without using GitHub Copilot because I don't do it 40 hours a week. I do it 5, maybe 10 hours a month. And because I can use that AI programming, I know what I need to do, but I can't remember all the symbols in my head, and GitHub Copilot still makes me a pretty effective data scientist when I need to be. Orchestration and deployment frameworks are another technology which are fundamentally changing the landscape. So people are no longer writing things that they run on their own computer. They're running things that can be written, built, and deployed in a deployment framework, potentially over an entire enterprise. There's always been this historic maxim with data scientists that 80% of your time is spent working with the data and conditioning the data, and then 20% of your work is actually on the actual data science, the actual algorithm that you might be using. But this tool chain is going to change that, that ratio. So what does this mean for the evolving skill sets of data scientists? The 2024 data scientist, even today, does a lot less munging of the data and a lot less model training because they have tools for automation of that. Now, not everyone may be adopting these right away, but in the future, this trend is going to continue to where manually tuning a model or manually munging data will be considered kind of like assembly programming like it was a couple decades ago. Corporate data teams have a much more structured focus on communication and ownership of business problems. 5 years ago, it was probably okay to get hired as a data scientist and just do kind of inbound data science work. Now, most data science teams I work with are assigned a value number. They have to recover $15 million a year from a particular business problem, and they work with stakeholders in that business to do that. Expert level skills for specific tools, especially these big data platforms, are necessary. They're necessary to build and they're necessary to maintain. So what do the roles look like? What does a new data scientist look like now, but also 10 years from now? Data engineering, I think, is a big one. So all of this infrastructure that you're building under the data scientist, someone needs to build it, they need to maintain it, they need to be data literate. Analytics developers, I think, are one big category. These are people who are not just building a data algorithm, they're working end-to-end on the software solution. Industry specialists and data translators, people who have skill sets and are subject matter experts in a specific industry, but then can apply data science skills to that and are working kind of with both sides of the skill set in order to build a data science application. These people are very effective because they can do kind of the whole enchilada. There's also data technology specialists, so people who are maybe a Databricks architect or people who work on the very, very core data technology that other data scientists or other data engineers might use. And then I've seen now, especially when it comes to security and compliance, roles like data ethicist, where you are looking at not just the use of data, but how you use it responsibly, how you're compliant with privacy laws and ethical concerns around AI. Closing thoughts, adaptability is key. Keep learning, and as technology evolves, so do the opportunities. Thank you.